The purpose of today's lesson, is proportional relationships and linear relationships. Oh boy, proportional as linear. Okay, linear, remember, there's a root word in their line, so that means it's going to be a line. Two cousins, Grace and Kelly, are both headed to the same summer camp. They both leave from their own house for camp at the same time. The graph below represents the girls' trips to camp. Okay, so this is Kelly in blue, Grace is in black. This is their distance from Grace's house in miles, and this is the time. Analyze the graph to determine which girl is traveling faster. Okay, well, let's take a look at this. We see that Grace is going the distance of, well, let's pick this point. Let's try to get to there. Let's go, her distance here is, what do you got there? 60. And the time is 1. Okay, so she would be going 60 miles in 1 hour. Let's see if that's consistent. 60 in 1. Yep, that's 60 in 1. Okay, so it looks like Grace is going 60 miles for 1 hour. Okay, now let's take a look at Kelly. Let's go a different color here. Kelly, she's starting here at 80, and she's going up, let's see, up to, let's find a point. Here's one. So we got to figure out how far this distance is, and this is still the 1. So 80 up to, what is this? This is a 140. So 140 minus 80 is, oh, wow, that's 60 to 1. All right, let's see. So each one of these is 20, so 20, 40, 60 to 1 again. Well, that's weird. Kelly is 60 miles in 1 hour also. Huh. So which one's traveling faster? Well, neither. They're both traveling at 60 miles per hour. Okay. Huh. All right. Do you notice anything about those lines? Yep. They're parallel. Well done. Alright, complete the table below for Grace and Kelly. Alright, I'm going to try to, that's why I made this smaller so we could use this. Alright, let's concentrate on Grace. She's in the black line. At 0, her distance, of course, is 0. And then we're going to take our y and put it over x. So we're going to put 0 over 0. Oh, okay. Well, that's the empty set. There's no such thing because 0 can't be in the denominator. Remember, this is undefined. No can do. Impossible. When she's traveling 1, she's at 60 miles. 1 hour is 60 miles. Well, what about 2? Where is she? Oh, I could just use my graph there. Oh, look, she went 2 hours. She's at 120. All right, so at 2 hours is 120. Oh, I forgot to do the y over x. So this is 60 over 1, which is 60. This is 120 over 2, which is 60. Where is she at 3? 3, she is at, where is that? 180. Okay, at 3 hours, she is at 180. 180 over 3 is 60. And at 240, she's going to be 4 hours away, and 240 over 4, I'm guessing you can figure this out, is 60. Okay. Huh. So it looks like they're all 60 except at 0. Let's look at Kelly. Now she's in the blue line. She's at 0. 0 over 0, once again, that's undefined. The time when she's at 120. Well, let's take a look here. Where is Kelly at 120? 120 is right here. Where is she? Where is that about? If you were to guess, let's see. Okay, my bad. I made a mistake here. At the time 0 for Kelly, she's already 80 miles closer. I'm sorry about that. Yeah, let's take a look here. Look at this. Kelly is 80 miles closer at 0 hours because she lives that much closer. So we're still going to get the empty set here because it's 80 over 0. Okay? But now, after 1 hour, if she's traveling 60 miles in 1 hour, she's already 80 closer, so she's at 80 plus 60. Okay, this shouldn't even be a 120. This should be a 140. I was wondering about that because after 1 hour, yeah, she's at 140. Yeah, so that's a mistake there. Okay, and then it's 140 over 1, so her rate is 140. Okay, and then after 2 hours, we should be able to use the graph for this. Let's see where Kelly is. Kelly is at she's at 200. Oh, gotta be careful with these guys, they get sensitive. 2 is going to be 200 because we have the 80 plus the 120. That's 200. So let's scratch that out. And then at 3 hours, let's see where she is for that. Back up there, come on, come on. 3 is at 260. Okay, and that would make sense because we're doing 3 times 60 plus the 80 is I think I said that wrong. It's 3 times 60 is 180 plus the 80 is 260. So here we have 200 over 2, and that's going to be 100. This is 260 over 3, and that's going to be 6 point something. And then at 4, so we could do 4 times 6 is 240 plus the 80 should be 320. So 320 over 4 is going to be 80. Alright, let's continue on here. And then it says, what do you notice about the ratios for Grace? Okay, what do we notice? This one is Grace. Look at the ratio. Huh. They're all the same. They're all 60. So for Grace, the ratios are all 60. What about for Kelly? This is Kelly over here. Oh wow, they're all over the board. 140, 100, 86 point something, 80. So for Kelly, it's inconsistent. We do not have the same ratios. So it looks like Grace is having a constant ratio. So that means that there is a unit rate. So Grace has a unit rate of 60 miles per hour. Kelly, she does not have a unit rate. It's not consistent. We discovered that. Describe why Kelly's driving relationship is not proportional. Well, there's 2 things we have to look for. Is it a straight line? Yes. So that's a yes. Does it go through the origin? Go through the origin. Does it? No. So if both of these aren't yeses, then it's not going to be proportional. So that would describe why Kelly's is not proportional. Is it possible to still describe the rate at which Kelly drives? Yes. Yes, we were able to figure that out because we were able to see that she went 60 miles in 1 hour. It's just that her starting distance is different. Okay, often the rate at which a relationship changes is shown by seeing sorry, that the changes from one measurement to another are proportional. That is, the quotient of the change in y values with respect to the x values is constant. This is called the rate of change. Both of the relationships described have a constant rate of change of 60. This constancy defines them as linear relationships. That means their graphs produce a straight line. So that's a linear relationship. Use what you have learned above to see if you can write an equation that represents each girl's distance, y, from Grace's house after x hours. Okay, so we're going to start with y equals. The rate of change was 60 for Grace, and that was after x hours. Well, wait, Kelly, she had the same rate of change, but hers is a little different. She started 80 miles closer. So her linear equation is going to look like this. So she gets to add 80, but she still had a constant rate of change. Okay. Agatha makes $26 for selling 13 bags of popcorn at the Doab County Fair. Find and describe the rate of change for this relationship. Okay. Complete the table that shows the amount of money Agatha makes for selling up to 3 bags of popcorn. Okay. So what is her rate of change? Well, she gets some money for every bag of popcorn she sells. And it looks like she's going to get $26 for selling 13, which the rate of change, or the unit rate, is going to be $2 for one bag. So the rate of change without the dollar sign is just going to be simply 2. So let's fill out our table. We're going to do 0, 1, 2, 3. Well, if she sells 0, she's not going to make anything. If she sells 1 bag, the multiplier is 2, or the rate of change. So this would have to be 2. 2 times 2 is 4. 3 times 2 is 6. So the rate of change is, you will see that it is going to be plus 2, because all of these are increasing by 1. There is a pattern that you're going to see each time. And notice that the rate of change is always going to be y over x. So it's the change 2 over 1. So go ahead and graph the dollars to bags of popcorn. So this is going to be your money here, and this is going to be your popcorn for your x. So go ahead and graph that line. Okay, did you get this graph on the same line on your graph? That's awesome. Okay, highlight on the graph where you can see the rate of change. Okay, so the rate of change is we go up 2 over 1, up 2 over 1, up 2 over 1. Alright, so we highlighted that. Write an equation that represents the relationship. So our multiplier was $2 for every bag. Okay? At the Sanpete County Fair, Fitz gets paid $8 a day plus $2 for every bag of popcorn that he sells. Okay? $8 a day plus $2 for every bag of popcorn he sells. Find and describe the rate of change for this relationship. Okay? The relationship is, the unit rate is $2 for one bag. So the unit rate is 2. Okay? Complete the table. Alright, let's do the same. Let's use those same numbers. 1, 2, 3. There, 1, 2, 3. Okay, what happens if he sells 0 popcorn? How much? Well, wait a minute. We've got some new information here. He gets $8 a day. So right off the bat, if he doesn't sell anything, he gets $8. That's a good gig. What happens if he sells 1? Well, he gets the 1, and then he gets 2 more because he sold 1 bag. So this ends up being an 8 plus 2. If he sells 2 bags, that's $4, and 8 plus 4 is 12, and then of course 14. Let's find our rate of change. Once again, it's plus 2, and over here is plus 1. Alright? Graph this relationship on the previous graph. Okay? Let's go back and find that, and that's going to be 8 up 2 over 1, so his is going to be way up here. Alright? And that's Fitz. That's a good name. Fitz. Alright? So we graphed that. Highlight on the graph where you can see the rate of change. Okay, let's go back again to the graph, and let's highlight the rate of change. Let's go ahead and do that. It's up 2 over 1, up 2 over 1, up 2 over 1. Okay, that worked. And then what's our next order of business? Write an equation. Alright, we can handle this. Alright. Okay, well, his rate of change was the same, so it's 2x. We're going to start with y equals, but wait a minute. What was that other little bit of information? He started at 8. So he started higher than the previous guy. Okay? This last part, I'm going to leave that up to you to finish. So you have 3f to bring to class. To class. Alright, this concludes our lesson on proportional relationships at linear relationships.